Hi everyone, welcome back. So today is our lesson 40 for the semester, and I'm going to go through what an arithmetic series is. So you know from a previous lesson that an arithmetic sequence is a set of numbers that are increasing by the same amount, right? So if we were to graph those values, it would be linear. Today we're going to look at finding the sum of all of those numbers in an arithmetic sequence, and that's called an arithmetic series. So just remember that the general term for an arithmetic sequence is, I'm just going to get my marker here, is this right here. Tn is equal to a plus n minus 1 times d, where a is the first term, d is the common difference, right? So what are those numbers increasing by? And then n stands for the term number. So like, for example, the fifth term would be T5, where n would be equal to 5. All right, so I'm going to go through 3 examples. So the first example is find the fifth term of the following arithmetic sequence. All right, so this is something that we've done already in the past, and then I'm going to use this example for us to find the sum of those terms, which would be the series. So to find the fifth term, I picked a really easy one on purpose so that you could do it without the equation to check if the answer is correct. Right, so for this sequence here, we have 2, 5, 8, 11. So we can see that they're increasing by 3. So our D is equal to 3. Our A, which is the first term, is equal to 2. And you could continue the pattern to find the next number to be 14, right? Because they're going up by 3. But I'm going to use the equation T5, all right, to show my work. Okay, so just using the equation up here, replacing the A with the 2, and then replacing the N with 5, because we're trying to find the fifth term. And then I replaced my D with 3 because the numbers are increasing by 3. And I got the answer 14, right? Which makes sense. 2, 5, 8, 11. The next one would be 14. Okay, so this is review what we've done previously. Now what I want to do is I want to use an equation for the sum, okay, for the series to find the sum of the first 5 terms. So again, I picked a really easy example because you could just add them together, right? 2 plus 5 plus 8 plus 11 plus 14, right, to get your answer. I want to be able to check our answer, so I picked an easy one on purpose. This equation here is what we are going to use to find the sum of those values. So if you add all those terms up, 2 plus 5 plus 8 plus 11 plus 14, you're going to get 40. Okay, we're going to use this equation to see if we get the same answer. The other equation that we could use is this equation right here, and this can be used if we know the first term and we know the fifth term, right? We know the last term, which we do in this case. It's 14 and 2. So we're going to do it twice. So using the first equation, I have that down here. All right, so just replace your n with 5 because we were looking for the sum of the 5 terms. Our first term is 2, and our d is 3 again, right? The same values that we used to find the fifth term up here. Okay, so we're using the same letters. If you plug those into your equation, you end up with 40, okay, which is what we did when we just added them using a calculator. And then using the other equation over here, okay, we know the first term is 2. We know the fifth term, the last term is 14. Add them together, you get 16 times 5, and then divided by 2, you get 40 again. Okay, so I picked an easy example, okay, so that we could check that in fact these values do add up to 40. Okay, but you can use those equations for tougher questions. All right, third example, find the sum of the first 20 terms, okay, so S20, if the fifth term is 13 and the ninth term is 37. Okay, so thinking back to the general term of an arithmetic series, okay, would be Tn is equal to a plus n minus 1 times d. So we're going to use this general equation, okay, when we're given specific terms. So we're given the 5th term and we're given the 9th term. So we can come up with 2 equations and then use that to solve for d and to solve for a, right? D, we want to know what are those numbers increasing by? How quickly are they growing? And a, we need to know what the first term is. Okay, so that's what I did over here. So using the information that the 5th term is 13 and that the 9th term is 37. Okay, so you can see that I've replaced my n with 5 and 9, and I've replaced the actual number, right, Tn or T5 to be 13 and 37. When you simplify the equations, this is what you have, 1 and 2. And now we need to eliminate. So we have an A and another A. So if we subtract those, that's going to eliminate the A, right? When you come up with your 2 equations, you want to eliminate one of the letters, right? Sometimes you have to multiply one of the equations by a common number before you can subtract or add. And yesterday's lesson, I showed you how we can divide the equations, okay, if they're divisible, to eliminate one. Okay, so I subtracted one second equation from the first equation to solve for d. So d equals 6. And now I can sub that d equals 6 into one of my equations, 1 or 2. It doesn't matter which one. You should get the same a when you solve. I chose equation 1. And I got a equals negative 11. Okay, so I know that my first term is negative 11. I know that my terms are increasing by 6. Okay, so they're going up by 6, starting at negative 11. So to find the sum of the first 20 terms, so S20, right, we want to use our sum formula. And we have our A and we have our D. And we also have N, because we're looking for the sum of the first 20 terms. Okay, plug them into the equation, and you should get that the sum is equal to 920. That's the second equation, or second or third example. One more example here, number 4. Find the 20th term. So 20th term means we're looking for T20. If the 7th term is 15, so we're given T7 is equal to 15, and the sum of the first 12 terms is 240. So S12 is equal to 240. So starting with the first equation, right, we are given that T7 is equal to 15. So since we're given that, we want to start with that equation. Right, we're going back and forth. I'm going to go back to the first slide. We're going back and forth between the general term equation, okay, and then we're also using one of the new sum equations. We're just going back and forth in between those, depending on what's given in the question. All right, so we're going to use the general equation here, and I went ahead and I replaced my Tn or T. We're given T7 with 15. And I replaced my, I just went and added the general equation there. I noticed you might be confused to know where this came from. Okay, so there's my general equation, a plus n minus 1d, and I'm given that my n is 7, right, because we have T7 equals 15. So that's where 15 equals a plus 6d came from. So that's my first equation. Now my second equation, I'm going to use this information here. The sum of the first 12 terms is 240. So Sn is 240. My n is 12. So I can put that in this spot here and that spot there. And I think that's all we're given here. Yes, we are. Okay, so I'm going to simplify this. So what I've done here is I divided 12 by 2. That's where the 6 came from. Okay, so now we have 240 equals 6, 2a plus 11d, right? 12 minus 1 is 11. So that's what we have at this point. And now dividing both sides by 6 to simplify further, all right? So they can cancel out, and 240 divided by 6 is 40. So there's my second equation. And I've got my first equation from the Tn, or from the T7 equals 15 that I came up with. So I just wrote them on top of each other like this, and I'm going to try to eliminate a letter here. So I noticed that the second equation has 2a, so I'm taking the first equation and I'm multiplying everything by 2. Okay, so equation 1 gets multiplied by 2. So I've got a new equation here. Okay, I multiplied the 15 by 2, the a by 2, and also the 6d by 2. The second equation I just rewrote underneath, and now I can subtract those two equations. So equation 1 times 2, and then I subtract equation 2. All right, 30 minus 40 is negative 10. These are going to cancel, and 12 minus 11 is 1. So we have 1d is equal to negative 10. Okay, so now I know what my d is. So I know that my numbers are going down by 10. They're decreasing by 10. All right, I still need to know what my first term is. So I'm going to use that, d equals negative 10, to solve for a. I'm subbing that into equation 1. So my original one up here. Okay, I could also do equation 2. Or the new equation here, the 30 equals 2a plus 12d. All of those equations are going to give us the same answer for a. So I'm subbing it into equation 1. So there's my equation 1. And I'm replacing the d with negative 10. 6 times negative 10 is negative 60. So we have 15 is equal to a minus 60. Bring the 60 to the other side, it becomes positive. 60 plus 15 is 75. So there's my first term. My first term is 75, and my numbers are decreasing by 10. And what was the question asking? The question said, find the 20th term. So find T20, okay, which means I need to use this equation, okay, because I'm finding the 20th term. All right, so that's what I have here. Okay, replace your n with 20, and replace your a with 75. We just found that. And replace your d with negative 10. All right, and then just solve, and you will have the 20th term, which is negative 115. All right, I'm going to assign some questions for you to try from the textbook, and I will list those in Google Classroom. Let me know if you need a bit of help. Just pop into one of our Google Meets. Have a great day.